what is the phase of each component. Now, I've seen people try to do this. They say, oh, hydrogen gas, they put a G in parentheses in the middle, and oxygen gas put a G in parentheses afterwards. No, it is the phase of the compound together. One phase per substance. One phase for hydrogen, one phase for oxygen, one phase for water. Okay? All right. Second thing we have to deal with. Diatomics. Diatomic molecules. Diatomic molecule means that there are 2 atoms per molecule. Now usually it means you have 2 of the same atom. Doesn't always. Like carbon monoxide is considered a diatomic molecule. But in this case we're talking about 2 of the same atom. There are certain atoms, and I did examples of those in the Lewis-Scott structures to show you that. That's why some of you got confused about SI. And I asked for your homework for SI and SE, and you gave me 2 SIs and 2 SEs. And I said, no, I didn't give you 2s for those. They're not diatomic molecules, so you never see them grouped up like that. But these are the elements that will be diatomic, and I'll write little 2's by them. It's going to look pretty familiar. Hydrogen is diatomic. So if you see a hydrogen, like we do up here, you got to put a little 2 there to show that it is 2 atoms per molecule. It is a molecule of hydrogen. A molecule of hydrogen has 2 hydrogens. All the time. Never fails. Go across here, the next one is nitrogen. Nitrogen by itself is always diatomic. Next one is oxygen. Oxygen is usually diatomic. Not always, but when we deal with these chemical reactions, it will be always diatomic. But there are such things as 1 atom per molecule, or even 3 atoms per molecule. That's called ozone. That's a pollutant in industrial areas. Next one is fluorine. In fact, all of the halogens here are diatomic. We don't care about acetate, but we will put down the others. Chlorine, bromine, and iodine. So we have 1, 2, 3, 4, 5, 6, 7 diatomic molecules that could potentially be involved in these equations. Okay? So we'll go back up. Oxygen's diatomic. We got to put a 2 there by that oxygen. Now, we come over here and say, oh, look, hydrogen's diatomic, but why do we put a 2 there for the oxygen? Because we only look at atoms by themselves. We're not looking at the molecule. If I put a 2 there, that's no longer water. That's hydrogen peroxide. You already heard my horrible joke about that, so I'm not going to continue with that. So that's the next thing we have to check for, which we just did. And then the last thing we need to do is balance the equation. You already know how to do that. We spent 2 lessons dealing with simple ones and complex ones. This would probably classify as a simple one, but let's just go ahead and do that. So let's go back and put this up. H2 gas plus O2 gas yields H2O liquid. And we'll put the line there, and we'll put the elements, H and O. And count the number of atoms we have of each. We got 2 hydrogens on the left, 2 oxygens on the left. On the right hand side, we have 2 hydrogens here and 1 oxygen here. So this needs to be balanced. Well, we got 1 oxygen here, 2 oxygens here. We can put a 2 right here. You have 2 oxygens. But when we do that, that makes that 4. Well, now the oxygen balance is not the hydrogens, so we go over here and put a 2 in front of that, and then this is 4, and voila, it is balanced. But that's not the only way. As some of you probably know, there's another way we could have done that, and it would be just as correct as what we just did there. And that is this. Down 2 hydrogens here, 2 oxygens here, 2 hydrogens here, 1 oxygen here. We've got 1 oxygen here and 2 oxygens here. Can we make that 2 a 1? We sure can. Remember, when we're changing 2 to a 1, use the fraction 1/2, and 1/2 of 2 is 1. So it could have been done like that. Okay? All right. Let's do another synthesis reaction or formation reaction. Make sure I'm not doing one that's a homework assignment. Okay, good. All right. Let's do this one. Nitrogen. Okay, let's not put it down. Let's write it another way. Give the synthesis reaction for ammonia. Okay? Synthesis. We're going to create stuff. We're going to synthesize. We're going to take the elements and add them together and get the compound. So, what elements are we going to add together? Well, we look at the compound. It's got 2 elements, nitrogen and hydrogen. Those are the 2 that are going to react. So this is what we call our skeleton equation. It's a foundation that we're going to build on, and we're going to put the 3 steps involved in there. First one being phases. What's the phase of nitrogen? One of the gases. Hydrogen, we already talked about, is a gas. Nh3. Now, is Nh3 ionic or covalent? Well, does it have a metal in it? The answer is no. So, that has to be covalent. And since I didn't tell you the phase, I assume that you know that it's going to be a gas. Okay? Now we check for diatomics. Is nitrogen diatomic? Well, it's on that list, so we put a 2 there. We already know hydrogen is diatomic, so we do that. And we don't worry about this because this is a compound, not a single element, so we don't put any 2s over there. We have 2 nitrogens, 2 hydrogens, 1 nitrogen, and 3 hydrogens. Okay? So if I want to get the nitrogens balanced, I'll put a 2 in front of the Nh3. That does indeed give me 2 nitrogens. And now it changes the number of hydrogens to 6. So fix that. I'll put a 3 right there. And it gives me 6 right here. And voila, we have a balanced equation.